Keep it simple, keep it simple, keep it simple. I've got a quick project this time. Really. I picked this guitar up from a flea market somewhere along the line. Life got complicated, and it ended up in the corner untouched for a couple years. Anyway, I had some free time and felt inspired, so I went to YouTube and found what looked to be a good exercise for learning where the notes are. Which is great, but it would be a bit of a pain to generate all the fingering charts by hand, and it would totally be straightforward to programmatically generate them instead. Super easy. In and out. I promise. I'm not going to repeat what this gentleman says, but essentially you go up and down the fretboard repeatedly across 5 different exercises to turn the note locations into muscle memory. Writing an application for this means displaying different things depending on which exercise I want to work on, which requires me to try my hand at handling the application's state programmatically. Most of the programs I write just do one task, which is the most basic kind of software to create. It's just a list of instructions that execute in sequence, one at a time. For the program to do different things, for example, display different graphics for the different exercises, I'll use variables to represent which exercise is selected and various other parameters, like the guitar tuning, and feed these into a set of conditionals to form a branching execution path. Then, in a different part of the code, I can scan for user input to update these state variables as needed, which means I've made a state machine. I created a struct to hold all the state variables. The obvious one is the exercise, numbering 1 through 5, and a settings page, which I set to be a value of 0. A less obvious one is the tuning that I want to use. I'll probably never use anything but the standard tuning. But as long as I'm generating all the fret to note mappings, I may as well make this modifiable, which means I need to represent each note mathematically. I decided to do this by mapping each note to an integer starting from C0. Using C as a reference point seems like common practice, so yeah. If you play piano, you're familiar with C4, which is middle C. The 12-note sequence C, C sharp, D, D sharp, E, F, F sharp, G, G sharp, A sharp, and B repeat as you ascend up note by note, and each iteration is an octave. I know I'm massively simplifying enharmonics and whatnot here, but I hope those intense music theory students who made it this far will forgive me. C0, which is as low as I'm going to go, is the sub-contra octave, and C4 is the one-lined octave. The standard guitar tuning spans E2 through E4. I assigned each pitch an integer value starting from 0 to represent C0. The standard tuning is highlighted here. Using this method, I can get the note by modulusing the integer value by 12. So, yeah. I can set the open string notes and the program will generate the rest of the notes on the fretboard. You can also see this small slider right down here for the offset. The notes repeat every 12 frets, but increasing this offset moves the 12th fret practice range up the neck of the guitar. So on I think it's a 21 fret guitar, I can practice the bottom or the top. Just change this setting. With all the notes calculated and the practice range set, the only thing left is to draw the actual diagrams. Toggling the all switch here draws all the natural notes in the specified range on the fretboard. Quick note about the fretboard. I figured this was algorithmically calculated, and it can be, so I did that here. Anyway, you turn off the toggle and you can select between 2 modes. One, which shows the notes by their finger placement, and a second that shows just the fret numbers in ascending or descending order. Some exercises require a sequence of notes. These operate in the same way in regard to the display, but I added this random button that can generate a random sequence for practice. The sequence can also be set manually by selecting a position first and then going and selecting a note. honestly, this interface is pretty clunky, a lot more than I would like. The interface elements that I'm using come from the Ray GUI header add-on to Raylib, and this is my first time trying it out. The documentation was a tad sparse, so while I couldn't make it how I wanted it, the functionality here is really useful and it saves a decent bit of effort. Though I'll probably have to make my own versions for any kind of official development project. Oh, these metronome toggles down in the lower right don't do anything. I wanted to play around with the Raylib audio functions to make an actual metronome. The exercises should be done at a gradually increasing speed. That said, the window updates at 60 FPS as a target. It can vary depending on how long the different tasks and functions take. To make a really accurate clock, I can use pthread to create a separate thread to take the metronome state data and then play a 440 Hz tone in time. That said, I can't use my virtual machine for testing because of some issues with the VirtualBox sound driver, I think. So I'll have to transfer the project to the Linux partition, and you know what? This is getting out of hand. I'd like to try this threading stuff, but this is supposed to be a quick project, and to be honest, I'm already kind of behind on my chores. Now, if you really want to run this program yourself, I'll post a link to my files stored somewhere. Don't know how I'm going to publish it, but if you run Linux, or probably a Mac, you can just download the files, open the location in the terminal, and then build and run it by typing /crun guitar. I may even write some documentation for it if I'm bored this week. Also, keep in mind, I didn't do anything to clean up the code, so there's a bunch of stuff that should probably be changed and sections that should be rewritten. The structure of the code also got a bit out of hand and could be cleaned up. Okay, short and sweet. Let's tally it up and... Oh. Well, I enjoyed it, so all's well. I'm gonna go make lunch. Do chores. Chores. Yeah.